Everyone, myself Vipin Tomar. I am doing my BTech in IIITM Kannur in branch Artificial Intelligence and Data Science. Today I am going to present my project which I have done for my SIC internship. Project name is Wildfire Detection using CNN architecture. First we will go through dataset, then we will discuss about how I build that model, and then we will see some outputs. Now, first of all, we focus on the problem. As you all know that wildfire are cause many problems and are unpredictable because of the changing in climate. So we are trying to take some satellite data and then predict the is there any wildfire for future or tomorrow. Okay. Our main goal is to we feed our model today's satellite image and some climate snapshot. Then our model will predict that in which area there is a possibility of the fire for tomorrow. For this, I use this data set from table. It has 1,000 to 8,000, 18,000 images from satellite and approx 8 year of data throughout the USA. And the main challenge in this dataset was imbalance of the dataset, because only 2% of the satellite images or a part of that image, only 2% of those pixels indicating the wildfire. So there is a imbalancing between fire or no fire. So that was the main challenge we face in this dataset. And this is the format which they provide on Kaggle. It contains that format was TensorFlow files which contain 13 flat arrays, in which 12 are the channels like the temperature, humidity, etc. And the 13th one was the fire masking. Okay. Now this is the description of all the 12 pixels, 12 channels, and each channel is 64 into 64. Now this is the imbalancing which I talked about, that no fire region is 98% and the fire region is 2%. Now this is the pre-processing phase which we give masking to those pixels, like those pixels which are not seen because of the cloud or etc. We give label as them -1, and then 0, 1 to those 0 with no fire, 1 with fire. Okay. Now this is the model architecture. We use unit architecture. As you can see that this is a U-form architecture which phase step by step extract the information from the image and increase the feature size, and at the bottleneck it will reconstruct those pixels while converting 12 into 64 into 64 batch into 1 into 64 into 64. This image will be only containing one channel which will be the prediction of the is there is a fire or no. Okay. Now this is the architecture background details, and these are loss functions which I use IOU and F1 score for the accuracy of prediction or performance of the model. And there are some loss functions which we use throughout the back propagation of the training of the model. Okay. Now these are also those calculations which we involve in the unit architecture. Now this is the training pipeline. We store the best model or final models so that we can analyze the performance of how the performance is increasing or decreasing throughout the training. Now for the validation, we get the accuracy of 97% and precision 0.7 for the validation, and AIU is 50%, which is basically for the seeing the imbalancing in the data set. This was the best IOU which can be get. see the validation and the testing result of our model. As you can see that we achieve accuracy of 97% and IOU of 50% regarding the imbalancing in the dataset. And there are some advantages of this model. This is the overall pipeline of the model, which we use Kaggle data and pre-process it or then training and validation. Now I would like to show you some demo of my project. As you can see, this is the web page where we can just upload our data in file, and we can predict, or we can just run a demo. It has on at a background, it has a file. It will predict its own for that demo file. Now you can see for the demo file, this is the vegetation satellite image, which show the where the vegetation high or low, so that model can learn that in where the vegetation is low, the fire will be chance of fire will be more. Okay, and there are some all other channels like this one. This will show the elevation, and following the pattern, we come to know that higher the elevation, more chances of the fire will be there. And there are some like this one. So this one shows the direction of the wind, and this will show the speed. Now there are some other channels, temperature and humidity and all other things. Our model will learn the parameter, learn the mapping or mapping between the features and how these features affecting that there will be a fire in tomorrow or not. And suppose we select a new file which has low fire chance, and we run our model to predict, and it will show that there are low chances that tomorrow will be fire. As you can see, there is this fire coverage is only less than 1%. As you know, in this data set, only 2% of the area will only shows there is a fire, in which area is fire. So we kept our threshold to 1%. If our model detect more than 1% of the pixel are detecting as fire, then it will show the medium, and if the model predict less than 1%, it will show low risk, and for the high, as you can see that this area, this is the probability of fire, and this is the area predicted by the model that there will be fire. Now you can check for another file which has high risk. Now it will analyze all 12 channel of that data, and it will showing that there are 12% of the pixels which are actually having the fire. As you can see that most of the pixels from that area are showing fire. This one image is covering 769 kilometer of area. Okay, now this is our project, and thank you for sharing.